are building a robot with the goal of automatically recognizing and picking up cigarette butt litter. Plus, it's going to record the location of each piece of litter. But how do we do that? It seems like a monumental task. Let's break it down. 1. Build the physical robot. We need to be able to move the robot in multiple directions, power the robot, have an arm and a claw for picking up trash, a receptacle to put the trash in, and we need to be able to talk to the robot without a physical connection. 2. Build a machine learning model that allows the robot to recognize litter. 3. Build a machine learning model that allows the robot to navigate autonomously. And 4. Capture location data when the robot locates a piece of litter and communicate this back to an external system. Last month, we were still here. We had the arm working, but we're still trying to get the robot to move in multiple directions. First, we found a 3D model on Thingiverse for the tracks and printed that bad boy out at the local library. Except we were missing a couple of key parts, so we had to do another print. And each time we had to spend money and then wait up to a week for the print and then drive an hour to pick it up. Then we had a faulty motor controller chip for actually controlling the motors, so we had to order a new one. But that's not even the end of our saga. It turns out that we were using the wrong chip entirely. Of course, when you ask, why isn't this working? The internet gives you mean answers by angry people and not, oh, here's what you should be using instead and why. The internet could be a tad nicer, it would seem. I finally found a forum with someone who had the exact same setup as us and was experiencing the exact same problem, and someone else had actually provided an answer. The chip we were using was antiquated, inefficient, and did not output sufficient amperage, so we bought a new one with a very long name and tried it out. Our next problem, as you might see here, is power. We needed a separate power source which would neither fry our Arduino nor provide too little juice. Conveniently, it can be bought at the exact same place as that new chip. Inconveniently, I didn't think to order it until 5 minutes after placing the first order. And wouldn't you know it, I need a USB-A to USB-A cable to connect the battery to the power supply for our motors. And it's not so easy to find, especially one that isn't 3 miles long. So we made another online order. And now, at last, we have a robot that moves without a cable. But wait, we've been connecting to the robot over Wi-Fi with Telnet, an old and insecure protocol. Why? Because it's easy and we wanted something simple to get started testing. But this won't work long term. Why not just use Bluetooth, I hear you ask? Well, eventually we want to have a whole swarm of robots doing the dirty work. And if we use Bluetooth, we'd have a limited number of connections. Plus we'd have to be right next to the robots the whole time. So Wi-Fi it is. For Wi-Fi, we have the option of HTTP requests, post, get, put, you know the ones, or we could use WebSockets. But what's the difference, I hear you ask? Very good question. HTTP requests are one time. The client makes a request to the server, gets a response if it's working correctly, and then it's done. WebSocket requests are continuous. Once connected, if the client can continuously send messages to the server and vice versa. WebSockets just make more sense for our purposes, so here's how we plan for it to work. The browser will make a GET request to the server hosting our website to get the web page used to control the robot. From there, the JavaScript in the browser will initiate a WebSocket connection directly to the Arduino. The Arduino completes the WebSocket handshake, and then the browser can send a steady stream of commands to our robot with minimal latency. So, first things first, we looked for a library. No need to code such a common thing from scratch, right? And we found one. Yay! Except it didn't work. I had to code the WebSocket protocol on the Arduino using only the Wi-Fi library. I made that robot do a handshake and read the data from the browser. I learned a lot about WebSockets in the process, and it doesn't look that flashy from the outside. After all, the robot still just moves around. Here it is working on our development environment. Okay, now to take it to production, and what's this? Errors? So it turns out that you can't connect a secure site, HTTPS, to an insecure, WS, WebSocket. In order to make our WebSocket secure, we need to add a security certificate to the Arduino. It should be supported, right? Okay, here's a tool right in the Arduino IDE to add it, and our board is not supported. So obviously we're frustrated, right? A lot of work has gone into this so far. So, after some research and some pondering, we came to the conclusion that we will need to, once again, change out electronic components. And now we're waiting on a Raspberry Pi.